In the last video, we looked at the full process for finding eigenvalues and eigenvectors for a 3x3 matrix. Much more common question is one like this, where you're given enough information to get going with a question. So take a look at this. The matrix M has eigenvector 1, -1, -2. Here's M, but it's got that K in it. Find K. Okay, well, if this is an eigenvector, it means that when we apply this matrix to this vector, what we get is simply a scaled version of that. So that is 1 times lambda, -1 times lambda, and -2 times lambda. And this should be enough now to find K. In fact, to find K and lambda. If I multiply across the first row, hopefully I can find lambda. So 1 times 1 is 1. 0, and then -1 times -2 is 2, so plus 2 should equal lambda. Look, we get lambda equals 3. So now I can multiply across the second row and get 1 times 1, -1 times k, -2 times 1, and that should equal minus lambda, which I now know is -3. So this is giving me minus k equals, well, this is -1, so add 1 to both sides, and I get k equals 2. You could check that third row just to check you got lambda correct. That's 2 minus 8, so it should be -6. Yes, -2 times 3 is -6. Okay, so there's the value of k, and we had that first value of lambda. Can you guess what a follow-up question might be? Well, we could ask then, find the other eigenvalues. And once you know one eigenvalue, it's much easier to find the others. So we already have our k equals 2, and one of the solutions, lambda equals 3. So let's go ahead and find all of them. So working out the determinant of this, it's 1 minus lambda multiplied by the determinant of this, which is just 2 minus lambda times 4 minus lambda minus 0. So that keeps that relatively easy and compact. Then it's -0 times some stuff, and then it's -1 times the determinant here. So -1 times the determinant of 0 minus this. So that's 2 times, well, let's flip that around. That's just 2 times lambda minus 2. Okay, this is actually not even so bad. Don't even need to do algebraic division here, because although I know that lambda equals 3 is a solution, I can see that I've got lambda minus 2 as a factor in both. So let's just write 1 minus lambda, 2 minus lambda, 4 minus lambda, and let's actually flip this back round. So we'll make it plus 2, 2 minus lambda. Now I can pull out the 2 minus lambda that's in both. So this one actually wasn't so bad, was it? Giving me lambda squared minus 5 lambda plus 4 plus 2, and this one factorizes as well, and that's just lambda minus 2 and lambda minus 3. So there's the lambda equals 3 from before. And look, we've got an interesting case here. We've actually got only one more eigenvalue, so a repeated one of lambda equals 2. Now, repeated eigenvalues, totally possible. What they entail for eigenvectors is a bit beyond the scope of this course. We're not going to get into computing that, but just so you know, what it typically gives us is, rather than a single eigenvector, it gives us a whole space. So imagine 2 eigenvectors, and then anything that can be made up of a combination of those. So it actually gives like an eigenplane, which is quite cool. Not going to get into how to compute those, but do feel free to explore it. But just so you know, repeated eigenvectors are a thing. They're fine. Okay, so that is how to solve that problem. I'll see you in the next video.